Okay, so welcome to the pre-recorded class discussion. No? This is in line with the ongoing maintenance of the internet infrastructure in the Philippines. No? So anyway, so this is our asynchronous task. No? So I will discuss the remaining part of the chapter 4, no? Para mapanood ninyo. Okay, so last time we are able to discuss stoichiometry, what's the concept behind it, no? And the concept is that it allows us, no, stoichiometry is there to allow us to measure the number of atoms, no, indirectly. So ang mga bagay na yun kasi, those stuff are important, especially if you are doing chemical reactions, no. For example, in producing medicines, no, in producing uh, different substances, no. So kailangan ng tamang stoichiometry. Okay? So ano yung important na idea na kailangan nyo ma-develop last time is ito, no. You should be able to know how to write the workflow for your stoic, no. So yan. So it is always when you are converting the mole of one substance to the other, ito na yung stoichiometry part, no. So itong nasa gitna lang yung stoichiometry part. Then the rest, itong grams to moles, this is the mass mole relationship lang, no. So in the mass mole relationship, ang kailangan nyo lang malaman ay ito lang, yung triangle ng, ayan, no, yung relationship ng mass ng mole and then the molar mass, no. So yan yung importante lang for the mass mole relationship, no. So how about the stoichiometry part? Sabi ko ito yung stoichiometry part, no. Itong conversion from one mole to another. So paano uli ginagawa yon? You derive the relationship of your substances in a balanced chemical reaction, di ba? So, tignan mo lang yung coefficients nila in the balanced chemical reaction. Then you can come up with the conversion factors you will need to convert the substance A into substance B. No? So, by this time, kailangan expert na kayo in balancing equations. No? So again, yung ating coefficients that gives us the stoichiometric relationships. No? These are the conversion factors we will need in order to convert one substance to the other. Okay? So yun lang. And then you were able to solve for the following exercises last time. The answer is posted on the PowerPoint itself naman na. Okay? So ngayon, let's proceed with the limiting and excess reagent. No? Just like in cooking. No? So what's with cooking? For example, I purchase a, let's say, a bottle of oil, no? And then 1 kilo French fries, no? So hindi pa siya luto, no? Fries, no? So kunwari ganun, no? So I purchase a bottle, 500 ml bottle of oil, and I have 1 kilo of French fries. Ang question done is that my chemical reaction or my cooking reaction would be like, I will have my cooking oil plus, let's say, French fries. So, after cooking, I will have my, ano ba tawag doon? French fries din naman, di ba? Ito, uncooked. French fries. Yun nasa product side ko, let's say cooked na French fries na. Oh, na ang daming O. Teka lang, ayusin ko nga. Cooked. So this is like my chemical reaction, no? If I'm going to cook French fries kasi wala lang, no? So I have my 500 ml cooking oil and let's say 1 kilo of French fries, no? Okay. So ito yung question here. Are you going to consume all the reagents here? When we say reagents, we are pertaining to our reactants, no? So the question is, if you are going to cook your food, are you going to use up all the 500 ml cooking oil? Gagamitin mo ba yan lahat, no? Siyempre hindi, 'di ba? Yung french fries, of course, yan yung uubusin mo. However, the cooking oil, you will not need to use all of them because that would be a waste of money, no? So, hindi yan advisable na lahat ilagay mo dyan unless you are deep frying. Pero for the french fries naman, it doesn't need to be deep fried, no? Minsan nga air fried lang, eh, no? Okay. So, the idea here is that one reagent is completely used up, the other reagent is not completely used up, no? May substance na uubusin, may substance na hindi, no? So, ano mapapansin natin, in doing this cooking process, no, may substance na matitira and may substance na mauubos during the cooking process, no, as we form the cooked french fries, as we form the products, no. So, with that, may tawag tayong limiting and excess reagent, no? So, what is limiting reagent? So, the limiting reagent are the substances used up in chemical reactions. Kumbaga sa cooking, ito yung ubos na ubos. Ito yung simot na simot yung substance, no? Kailangan siya gamitin to create the product, no? Kailangan ubusin yung reactant na yon, no? And the excess reagent, this is the substance that is not really consumed totally, no? Hindi siya inuubos, no? So that means may leftover sa kanya, no? So, in our cooking analogy, ano kaya excess reagent dyan? So, of course, your excess reagent would be the cooking oil, no? So, this will be your excess reagent, no? And this will be your limiting. So, bakit, no? Because if you want to create maraming french fries, all you have to do is to consume all the french fries you have, no? Onti lang yung 1 kilong yan, eh. Okay? Pero yung cooking oil, hindi nga sila kailangan ubusin lahat, no? Kasi sayang yung mantika, no? So, ibig sabihin may matitira dito after cooking, di ba? Okay? So, that's why we have a concept of the limiting and excess reagent. The limiting reagent is necessary for the reaction to proceed. So, siya yung kailangan ubusin for the formation of products, no? However, the excess reagents, hindi sila necessary ubusin because from the word itself, they are in excess, no? May sobra talaga sa kanila, no? So, not all of it will be consumed, no? May mga matitira, okay? So, that's one analogy, no? So, let's have another cooking, analogy. Let's say you have flour and then egg, no? Siyempre, iinitin mo yan. Let's say, gumagawa ka ng, pancake, no? Pancake na walang flavor. Masyadong malungkot, no? Pero sige, so let's have pancake, no? The basic pancake. So yan, iinitin mo yan. So may heat symbol doon, may delta. So iinitin mo yan. So may mix mo yan. You mix it well, then you create the pancakes na, no? Siyempre, lagyan mo ng sugar, so on and so forth, no? Okay, so kunwari ito, let's have plain pancake lang. So I have flour and egg, no? Kunwari, I only have 10 pieces of eggs, pero I have 50 pounds of flour. Dami, no? Bakery ka kunwari, tapos ubusan ka ng egg, no? So let's have this example. Which of the two is the limiting and the excess reagent, no? Siyempre, obviously, yung flour, yung magiging excess reagent natin. Why? Because, let's say, kunwari ang recipe natin ay 1 egg equivalent to, I mean, yung 1 cup ng flour, that's equivalent to 3 eggs, no? So, kunwari yun yung recipe natin, no? So, 1 cup of flour, 3 eggs, you will have pancake, no? Parang masyado ata maraming eggs yun. Anyway, so hindi ako nagluluto, so I don't know the proper mixture. Pero kunwari, yan yung yan yung components natin, no? So kunwari, ito yung stoichiometric relationship nila. Ito yung mga coefficients, no? So I need 1 cup of flour and 3 eggs so I can make pancakes, no? So, sino yung limiting, sino yung excess, no? So by looking, I have more than enough number of flour. So I have more than enough amounts of flour para sa 10 egg, no? Because if I have 10 eggs, ilang cup ng flour yung kailangan? So we can do that using stoichiometric relationship or just conversion factor. So ilang cup ng flour kailangan to create uh, to use up the 10 eggs, no? So pwede natin gamitin yon using conversion. So we have 10 pieces eggs. Alamin natin kung ilang cup of flour ang kailangan. So according to the stoichiometric relationship, no? For 3 eggs, you have 1 cup of flour now. Cancel natin yung egg. Then that's 10 over 3. That's 10 over 3. Wait lang, calculate. 3.33. No? So 3.33 cups. Pero how much do you have? You have 50 pounds. So, itong 50 pounds na to, this is a lot, no? This can feed many people na, no? So, yan. So, we can obviously see that the egg would be our limiting reagent and the flour, no, will serve as our excess reagent, no? So, parang ganun yung idea, no? So, kunwari, this time, paano yung ginawa natin? This time, meron tayong stoichiometric relationships na. May proper recipe na, no? So, for every cup of flour, you have to have 3 eggs, no? So, ang case ko, I have 10 eggs eh. 'Di ba? So, 10 yung eggs ko. Then, ang question ko doon, ilang cup ng flour kaya? Siyempre, hindi mo ibubuhos lahat ng flour, no? Maninigas yan, no? Walang mangyayari, 'di ba? So, kailangan nasa tamang proportion yung amounts ng flour. So, inalam natin how many cups of flour yung kailangan. So, that's this equation, 10 cups, 10 pieces of eggs times 1 over 3. 1 cup of flour over 3 eggs. No? Cancel mo yung eggs, you have 3.33 cups. No? So, we just observe na yung 3.33 cups ng flour, hindi naman yan magiging 50 pounds ang weight. No? Grabe naman yung kung ganun. No? So, that means the flour is in excess. No? We only need 3 cups, no? Or just a few grams. Siguro wala pang ang kilogram yan eh. No? Pero what we have is 50 pounds now, which is way more than we needed now. So we say that the flour is the excess reagent and the eggs are the limiting reagent na. So parang ganun lang yung concept. So ano mapapansin nyo? In solving the limiting and excess reagent problems, you have to convert your amounts of substance, the amounts of your substances, no? Okay? Para malaman mo yung right proportions, no? So anything that is excess, yung sobra sa required, that is your excess reagent, no? And yung sakto lang, that is your limiting reagent, no? Okay, so I think that's enough cooking stuff, no? Kasi I don't know how to cook naman talaga. So let's proceed with the chemistry stuff, which I know, no? Okay, so let's have this example. So we have this recipe, no? Let's say recipe to kunwari na, para hindi siya intimidating. So we have this recipe, 1 mole of ammonia, 1 mole of nitrogen gas reacting with 3 moles of hydrogen gas, producing 2 moles of ammonia. No? So yan, ito yung recipe natin. Isang mole neto, 3 mole neto, you will have 2 moles of the product. No? So suppose we have 3 moles of N2 and H2. How much NH3 will be formed? No? Ito yung thing with the limiting and excess reagent problems. Usually, dalawang substance yung binibigay yung amounts. No? Dalawang substance yung binibigyan ng amounts. No? So, meron tayong 3 moles ng N2 and 3 moles ng H2, sabi sa problem. So, if you have 2 givens, no? May dalawa kayong given amounts ng reagents, no, or reactants, ibig sabihin nun, your question is about limiting an excess reagent. Pero kapag isa lang, yun yung typical stoichiometry problem, no? Charge ko lang. Okay, so again, how will you distinguish kung yan ay limiting an excess reagent problem? Kung mapapansin nyo sa question, you have two or more given substances. No? So yun yung key. Pero kung pag isa lang yung given substance, then you do the typical stoichiometry. No? So, pero this time, yun nga, sabi ko nga, may dalawa tayong given na substance. No? So we have 3 moles of N2 and 3 moles of H2. So for us to identify which of the two is the limiting reagent, no, or the excess reagent, what we have to do is to check how much product will be formed from each amounts of reactants. No? So alamin natin kung gaano karaming product yung magagawa ni H2, gaano karaming product ang magagawa ni N2. Okay? So let's do that. No? So we have the mole of ammonia from H2 and the mole of ammonia from N2. You have to do this? Yes, no. Gagawin talaga to. So ganito yung ginagawa, no? So you get the amount of products, no, or the desired substance from your reagents, no. So um you have the ammonia coming from the H2 and the ammonia coming from the N2, no? So yun, so may tig 3 moles sila. Then i-convert lang natin sila into NH3, no? So ito yung conversion for NH3 and H2. Saan galing yan? Sa stoichiometry, no? For every 3 moles of H2, there will be 2 moles of NH3, no? So, kaya we have this fraction here. Dito naman sa baba, this fraction here, this conversion factor, is from the ratio of N2 and NH3 in the balance equation. So, for every mole of N2, you will have 2 moles of NH3. Okay, so ganun lang. I-convert nyo lang yung reactants nyo into the products. No? So, dalawa yung i-convert nyo. Yes. Medyo ma-effort na. Pero kayang-kaya yan. So, you convert this. So, you will have 2 moles of NH3 from H2 and 6 moles of NH3 from N2. Okay. So, the question here is, which of the following is the limiting and the accessory agent? So, ito yung first key na you have to keep in mind. No? So it is always the limiting reagent that will give you the least amount of products. No? So yung limiting reagent, siya yung magle-limit ng dami ng products. So when we say limit, no, ibig sabihin nun, onte lang yung mapoproduce na product. It cannot produce more products than it can kasi ubos na siya. Okay? So yun yung idea dito. So, to know kung sino yung limiting reagent, all you have to do is to check kung sino yung may pinaka-onting products na magagawa. No? In which, for this case, is H2. Okay? So, si H2, siya yung pinaka-onte yung product na na-produce. Can it produce more? Hindi na. Bakit? Ubus na siya. No? So, hindi na siya pwede mag-produce ng more than 2 moles of ammonia. Kasi, ubos na siya by that time. No? So, technically consumed na siya. So, that means this is our limiting reagent, yung ating hydrogen gas. Looking at N2, for it to be consumed completely, para maubos yan ng kompleto, it can produce 6 moles of ammonia, which is way too far than the capacity of the hydrogen gas. No? So, sobra-sobra siya sa kaya ng hydrogen gas. No? So, that means this is our excess reagent. No? Okay, so ano uli yung way for us to distinguish which is the limiting and the excess reagent? So, ganito lang. You convert your reactants into the products. No? Isang product lang. No? Okay, so yan. Pag na-convert nyo sila, you check the amounts, no? It could be in moles, pwede rin grams, no? Pero mas convenient if moles na lang yung gamitin nyo. Okay, so yun, convert nyo yung reactant to products, no? Then check nyo kung sino yung may pinaka-onting products na mabubuo, no? The substance that will produce the least amount of products is our limiting reagent, no? It cannot produce any more, no? Any longer. Hindi na siya pwede makadagdag pa ng amounts kasi ubos na siya. So that means it limits the reaction. Yun yung lowest products na magagawa nga, no? Okay. Paulit-ulit ako dun, na. Pero yun yung idea. Nang gusto ko lang i-reiterate that yung onting amounts ng products na mapoproduce from the reactant, yun yung limiting reactant, no? Or limiting reagent. Yung sobra-sobra mag-produce, yun yung excess reagent, no? So, in conclusion, H2 is the limiting reagent and N2 is the excess reagent. And in total, no, in theory, gano'ng karaming products yung mabubuo? Only 2 moles of NH3 will be formed at the end of the reaction. So, ibig sabihin, hanggang 2 moles lang ng products yung pwede magawa. Hindi siya pwede maging 3, 4, 5, 6. No? Bakit? Kasi nga, since ubos na yung isang reagent natin, since ubos na yung H2 natin, the reaction will stop. No? So, naubusan ka na ng H2. So, hindi na yun tutuloy. Na? So, again, when our limiting reagent is fully consumed, that is the end of the reaction. No? So, kung gaano karami na produce niya, hanggang dun lang yung kaya ng reaction. Hindi na pwede magkaroon ng more. Bakit? Kasi ubos na siya. Ano? So, wala ka nang magagawang ano, wala ka nang magagawang products. No? So, balikan natin yung ating French fries analogy. So, kunwari, you have 500 ml ng mantika, nilagay mo lahat. Tapos, yung fries mo, um, 1 kilo pa rin, no? So, by the time na ubos na yung fries, marami ka pang mantika. Okay, so ibig sabihin nun, yung dami ng French fries na mabubuo mo ay limited lang sa dami ng limiting reagent mo. So your products, the amount of your products, your yield, no, depends on the amount of the limiting reagent, no. So kapag ubos na yung limiting reagent mo, yung fresh na French fries, pag ubos na yon, wala na. Hindi naman pwede yung mantika maging fries, di ba? Kasi kung ganon, di masaya ang buhay. But that's not the case, no. So yun lang. So again, the reaction yield, no, yung amounts ng products na mapoproduce will depend on the limiting reagent, no. So, amounts of products the amounts of products depend on depend okay, so the amounts of your products depends on the limiting reagents, no. So, kung hanggang saan lang yung kaya ng limiting reagent, hanggang dun lang. Okay? So, yun lang. So, let's have some exercises, no? So, medyo patapos na tayo, no? So, let's have this, no? Oh, I have 3 problems. Since asynchronous to, sagutan ko na lang lahat kasi wala naman akong kausap dito, no? Okay. So, sige. I will answer the 3 problems and I want you, no, as you watch this video, ano rin, sabayan niyo ako, no? Okay, so para matuto. Then, by the way, nasa PowerPoint naman yung solution, no? Pero let's do it manually, okay? So let's have this. Question number 1. Suppose we have 50 grams of carbon. It's mixed with 25 grams of oxygen. What is the limiting and excess reagent? How many grams of the product will be formed now? So what can you notice is that you are given the amounts of your reactants. No? Pag dalawang amounts ng reactants yung binigay, limiting and excess reagent problem yon. Okay? So ano yung dalawang amounts ng reactant? 50 grams of carbon and 25 grams of oxygen gas. No? There's some question, what is the limiting access reagent? How many grams? Okay, so ganito lang yan, no? So, for you to answer this, you should have chemical equations, which is this one. Ang question dyan, is that balanced? Is this equation balanced? Hindi. No. So, you only have one carbon here. You have one carbon there. Balance pala. Nasa isip ko carbon monoxide ulit. So, you have two oxygens here and you have two oxygens there. So, the equation is balanced pala. Sorry. Uh, okay. Anyway, so balance yan. So, proceed na tayo. So, let me rewrite the problem. So, we have carbon plus oxygen gas producing carbon dioxide. Tama? Okay. So, according to the problem, we have 50 grams of carbon and 25 grams of oxygen. How much carbon dioxide will be produced now? Okay, so ganito lang yan. So, ano sabi natin? We are going to convert our reactants to the products, to the product na CO2. Okay, so ganito gagawin natin. We are going to obtain the moles muna, no? Obtain the mole of carbon dioxide that you can obtain from carbon and the mole carbon dioxide that you can obtain from oxygen. So ito yung first step na. Identify how much products can you form out of your reactants na. So, yan. Kunin natin yung moles ng carbon dioxide no, from carbon and moles ng carbon dioxide from oxygen gas. Okay? So, gawin natin yan. Siyempre, carbon to, yung mass niya, let's convert that to moles muna. No? So, let's do that. Paano? So, that's the mass of carbon divided by the molar mass of carbon. So, after doing this, you have the moles of the carbon already, di ba? Okay. So, since you have moles of carbon already, you can now convert that into moles of carbon dioxide. So, multiply ko na. No? So, ano mapapansin nyo, diniretso ko na. Okay? So, after obtaining the moles of carbon, I will convert it to moles of carbon dioxide. So, ano yun nandito sa susunod? Nandito sa next part ng equation ko would be my stoichiometric relationship na. Okay. So, look at the equation. The coefficients are all 1 naman. So, sige. So, that's 1 mole carbon that will give you 1 mole of CO2. Diba? Okay. Then, by doing that, you have the moles of carbon dioxide already. Na. Punta naman tayo sa baba. Yung format ng ating equation dito is the same as yung gagawin din natin sa baba. So, let's just copy that, no? Pero instead of using carbon, we will use oxygen instead, no? Okay, so ganun yung format. So, carbon, carbon, carbon. Ngayon naman, O2, O2, O2. So, paulit-ulit yan. So, yun. Pero ano yung purpose, no? This part of the equation, itong part na to, this will give us the moles of our reactant. This part of the equation will convert the moles of your reactant to the desired product, no? Okay, so then we will compare then after, no? Sige. So anyway, baba ko muna to. So let's solve na. So mass ng carbon is 50 grams. Molar mass ng carbon is 12.011 grams per mole times the conversion factor. 1 mole CO2, 1 mole carbon. Okay, so the grams will cancel, the mole will cancel. No? Okay, so solve ko lang. Diretso ko na. 2 decimal places na. This is 4.16 moles of CO2. Sa oxygen naman tayo. So we have 25 grams of oxygen gas. Molar mass ng oxygen gas. 31,998 Gmol times the conversion factor, 1 mole O2, 1 mole CO2. Okay? Cancel yung grams, yung moles, they will also cancel. Okay? Let me solve. Okay, so this is our solution. So, from the amount of your carbon na meron ka, you can produce up to 4.16 moles of CO2. Dami, no? However, with the amount of oxygen present, no, yung 25 grams na yun, you can only produce 0.78 moles of CO2. Okay? Highlight natin. So, with carbon, yan ay 4.16 moles ng CO2 ang kaya ma-produce. For oxygen, hanggang 0.78 lang yung kaya. Okay, so the question is, sino yung limiting reagent? So obviously, your O2 is the limiting reagent. No? Bakit siya naging limiting reagent? Because it only produces few amounts of your products. No? Onti lang yung products na napoproduce ng limiting reagent. It cannot produce any more. No? Wala na, hindi na pwede siya magdagdag pa. Bakit? Ubus na eh. So hanggang doon lang yung amounts. Hanggang 0.78 lang pwede. Anything beyond that, hindi pwede na. Ubus na yung oxygen natin. Unless mag-refill ka, no? Pero hindi yun yung case sa problem, no? So O2 is our limiting reagent and carbon would be our excess reagent, no? So ganun lang yung pag-solve, no? So ayan, so we just identified sino yung limiting, sino yung excess. Question, how many grams of the products will be formed? Okay, so if you are asked how many grams of products can you form, no? Kapag ganun yung question, ano sabi ko sa inyo? Urong ko lang. So sabi ko sa inyo kanina that the amount of the product, no? The amount of the products produced in the chemical reaction depends on the limiting reagent, no? So, yung mole ng ating carbon dioxide from oxygen ang gagamitin. Okay, so we will use the amounts, no, the yield from the limiting reagent. Okay, so ito kasi yung basis natin. Hanggang dito lang yung kaya. No? Ito yung ceiling. Hanggang dyan lang. Okay, so ito yung gagamitin natin. So, grams of product formed. Again, pag ganito yung question, tinanong sa inyo how much of the product is formed, you will use the limiting reagent, no? So, nasabi ni limiting reagent, 0.78 moles of CO2 can only be formed, no? So, hanggang dyan lang. Okay? So, ngayon, convert ko yan into grams. So, that is just mass-mole relationship, no? So, that's mass CO2 equal mole CO2, molar mass CO2. Okay? Urong ko lang. Ayan. Oops. Okay, so that's mass ng CO2. Mole ng CO2, 0.78 mole times molar mass. $44,009 Gmol. Cancel yung moles. So you're left with grams, no? Okay, so the final mass of your CO2 that you can form is 34.33 grams only. Okay, so hanggang dyan lang karami yung products na pwede magawa, no? Okay, so ganun lang. So, yan lang. Ganun lang siya ka-easy, no? So, itong answer na to, screenshot ko to. I will send this in your group chat, no? Okay, para may reference kayo. And the answer is already on the PowerPoint naman, no? So, you can check that, no? So, dito yan, no? Close ko lang. Discard. So, punta kayo dito. Ayan. And so you can see only 34.38 grams of products will be formed. So ganun lang. So paki-check na lang itong answers sa PowerPoint na. Okay? So ganun lang. Or ito na lang na. Sige. So I will proceed with number 2. No, number 2. Okay, so let's check this. Methane is produced by the reaction of 10 grams carbon and 10 grams hydrogen gas. What is the limiting and excess reagent, and how many grams of the product will be produced? Okay, so ang tanong dito is similar with the previous one. No? So you have 10 grams of carbon, 10 grams of hydrogen gas. What is the limiting and excess reagent, and what is the actual amount of products na mapoproduce? No? Ano yung kanyang theoretical yield? No? Okay, so alamin natin yung actual amounts na kaya niya i-produce. No? In theory. Okay, so let's do that. So let me just copy the equation. Ano yun? Carbon. Okay. Okay, so this is our equation. We have carbon reacting with hydrogen gas to produce methane. Ito, question, is the reaction balanced? Hindi, no. We have one carbon here, two carbon here, two hydrogens here, four hydrogens there. So to balance that, lagyan mo lang ng 2 yung hydrogen gas. Then ano sabi sa problem? We have 10 grams of carbon and 10 grams of hydrogen gas. So we have to convert them to the product, no? So we can identify which of them is the limiting or the excess reagent, no? So let's do that, no? So this is mass methane, mass of product from carbon, and mass of your product from hydrogen gas. So again, the format is still the same. You obtain first the moles of your reactants, no? So paano yon? Mass ng carbon divided by molar mass ng carbon. Then, yung moles ng reactant nyo, i-convert nyo into the products, no? Using the stoichiometric relationships, no? So we have 1 mole of carbon that is equivalent to 1 mole of methane. Okay, so let's do that. So that's 10 grams divided by 12.011 gmol times 1 mole CH4, 1 mole C. So the grams will cancel, the moles will also cancel. Ilang CH4 mapoproduce from carbon? Solve ko lang. 0.83. No. Okay, so that is the only amounts of products that we can form from carbon. Okay, from 10 grams of carbon. So let's try hydrogen gas. No. So paano uli? No. So you convert your reactant. No. Yung gawin mo yung mass, gawin mong moles ng reactant. Then after having the moles of your reactant, you will convert that to the moles of product using the stoichiometric factors or the stoichiometric relationships. No? So we have mass of hydrogen gas, which is H2, molar mass ng hydrogen gas, times yung stoichiometric factor na. We have 2 moles of H2, and that will produce 1 mole of CH4. Okay? So, saan galing yung 2? Nung binalance natin yung equation, I placed a coefficient 2 there, no? Para maging balance. Okay, so let me solve this naman. So that's 10 grams of hydrogen gas divided by 2.016 gmol times the conversion factor, 1 mole. Okay, so solve ko lang. So that's 2.48 mole CH4 from H2. Okay, so these are the respective amounts of products that we can form from our reactants. No? So if we consume all the carbons, we will have 0.83 moles of methane lang. If we consume all the hydrogens, we can produce up to 2.48 moles of the product. Question, sino yung limiting? Sino yung excess? By just looking at the amounts of the products that they can form, yung carbon, this will be our limiting reagent na. Okay, so hanggang dyan lang yung kaya niya. Hanggang 0.83 niya. Pag sumobra yan, wala na. Ubos na siya. No? So, hindi na pwede siya maging 1 mole of product. Hindi na pwede yung 2 moles of product. So, hanggang dyan lang yung limit. Kasi hanggang dyan lang kaya niya. No? So, okay na yan. No? So, that means that is our limiting reagent. Hydrogen gas is our excess reagent. No? Okay, so ganun lang. No? Then, ang question dun, sabi dito, how many grams of product will be produced? Okay, so tanong sa atin, the amount of product will be produced, grams of CH4 that will be produced. Okay, so pag yan yung question, ano yung basis natin? The basis would be the amount of product that the limiting reagent can produce. So, itong 0.83 moles. Ito lang yung kaya, no? Okay, so hanggang dyan lang yung kaya. 0.83 moles lang yung kaya ma-produce. But the question asks us about the grams. Grams yung kailangan. So we will just convert the moles into grams. No? So that's grams CH4 equals, zoom in tayo, mole CH4 times the molar mass of CH4. 0.83 moles times molar mass. Solve ko. 16,043 gmol. Okay. The moles will cancel, giving us 13.32 grams of CH4. Okay, so that is our final answer. No? So the final answer is that only 13.32 grams of methane will be produced. Nothing more. No? Hindi na pwede sumobra. Bakit? Ubus na yung carbon. Hanggang dun lang yung kaya niya. Okay? So that's how you solve limiting and excess reagent problems. No? So may added step lang. Yes. May added step lang. Kasi dalawang beses ka mag-convert. Pero the concept is basic lang. No? So yung pinaka-onting amounts of products, yun yung limiting reagent mo. Yung pinakamaraming amounts of products na na-produce, yun yung excess reagent mo. Okay? So, ganun lang. Then if tinanong sa inyo how many grams of the products na na-produce, you will use the moles na mapoproduce ng limiting reagent. No? So again, the basis for the final amount of product is on the limiting reagent, no? Not on the excess. Huwag nyo to gagamitin. Ito lang, yung limiting lang. Okay? So, ganun lang ka-simple. Then, let's have the last one. Mas madali pa yung last one eh. Methanol is formed when carbon monoxide and hydrogen gas formed from carbon monoxide and hydrogen gas at high temperatures. Suppose we have 4 moles of carbon monoxide and 6 moles of H2, determine the limiting and excess reagent. So, hindi naman tinatanong kung gaano karami yung products na mabubuo. No? Pero we are asked kung sino yung limiting, sino yung excess. No? So, again, do not judge by the number. So, hindi porket mas mababa yung 4 kaysa sa 6, ito na yung limiting. No? Not really. We have to check stoichiometry. No? Check natin yung stoichiometry. Okay, so bawal ang judgmental. Hindi porket maliit yung number dyan, limiting na yan, no? Pwedeng limiting siya, pwede ring hindi, no? So, the only way to check that is by doing the stoichiometry. So, walang shortcut, okay? So, paano yan? Wala tayong equation. So, we have to create equation out of the word, no? So, sabi dito, methanol is formed from, no? So, andyan yung keyword natin na from. That means this is the product and these are the reactants, no? So, ganun lang. So, you have CO, hydrogen gas, CH3OH. Okay, so ganun lang. Then you balance it, no? So, we have one carbon here, one carbon there, one oxygen here, one oxygen there, two hydrogens here. We have 3 plus 1, 4 hydrogens, no? So, to balance that, I will just place a coefficient 2 sa harap ni H2. So, balance na yan. Okay, so for me to check kung sino yung limiting and excess reagent, all I have to do is, to convert 4 moles of, so let's 4 moles of carbon monoxide to methanol and 6 moles of H2 to methanol. No? So, ganun yung gagawin natin. So, mole CH3OH from CO. Okay, so paano yan? So, this time, hindi na natin i-convert yung grams to moles kasi naka-mole na siya, no? So, ano na lang gagawin natin? Yung mole ng reactant natin, i-convert natin to methanol by using the stoichiometry, no? The stoichiometric relationship. So, you now have mole of CO. I-convert mo na lang yan to mole of methanol, no? Ay, sa baba pala yung CO. So, we can cancel that. 1 mole, 1 mole. Okay? So, that's 4 mole, 1 mole. Cancel lang. Cancel, cancel. So, you will have 4 moles of methanol na that you can produce out of 4 moles carbon monoxide na. So, let's do this H2. Ilang moles yun? 6. So, 6 moles H2. Convert natin yan to methanol na. 1 yung coefficient. Dito naman ay 2. So, tamang convert lang. Cancel, cancel. So, that's 6 over 2. That's 3 mole CH3OH na. Okay, so by just looking at that, judge natin which is the limiting and the excess reagent na. So, H2 produced only 3 moles of the product. CO, carbon monoxide, produced 4 moles of the product. So, yung pinaka-onte, edi yung 3. So, that means our H2, this is the limiting reagent, no? Reagent. So, siya yung LR natin. So, yung carbon monoxide, this is our excess reagent now. Okay? So, ganun lang ka-simple. So, ano yung i-assign ko sa inyo, no? So, remember in your canvas, no? Punta lang kayo ng canvas. Tagal magbukas, ah. Medyo mabagal kasi minsan yung internet talaga, no? Dama ko rin yun, eh. So, just go to your canvas sa discussions for the laboratory. Ba't nag-close to? So weird. Nakalimutan ko tanggalin yung close. Anyway, so just go to your canvas, no? Sa laboratory, punta kayo sa worksheet. So I want you to answer the rest of the items. So last time pinasagot ko lang sa inyo yung 1 eh. 1A, B, C, di ba? So with the idea of limiting an excess reagent, you can actually solve for the other problems, no? So yan. For example, ito, how many grams of NO can be theoretically obtained? How many grams of excess reagent are unused, no? What is the percent yield, no? So ito, if 5 grams of each reactant, meaning tigli-5 na ito, 5 grams na ito, 5 grams na ito, 5 grams na ito, how much this product will be produced? So that is a trick question. So yeah. May mga trick question dito. So the goal is not to make it hard for you kasi paulit-ulit lang naman yung concept. But the goal is para ano yung isip natin, no? Matrickle para makasagot kayo ng mabilis, no? So, yun. So, kailangan kasi kinikiliti yung ating brain, no? Para makasabay siya, no? Okay, so that's the limiting and excess reagent, no? So, let's now proceed to the last part of our topic, which is the percent yield, no? So, what's percent yield, no? When we do chemical reactions kasi, we do not obtain the complete amounts of products, no? Ibig sabihin nun, yung amounts ng french fries na ini-expect natin, hindi talaga yun yung amounts ng french fries after doing the reaction. Bakit? Yung iba kasi nahuhulog, yung iba sunog na, so on and so forth, no? So, ganun din sa chemical reactions. When you do chemical reactions, hindi lahat magagamit, no? Hindi lahat magiging products, no? So there are lots of reason kung bakit. Number one is purity of the reagents, no? Mamaya kasi yung reagent pala marumi, hindi pala siya pure. So it will give you lesser yield, no? So onti yung mabibigay niyang amounts of products instead, no? So yun. So yun yung one factor, purity. Pwede rin experimental setup, no? Kunwari, ang kailangan sa experiment, lagyan mo siya ng takip, no? So, ay tinanggalan mo ng takip. So, magbabubble out yung mga reagents, no? May mag-escape. So, that will give you lower amounts of products than expected, no? So, yun yung mga factors that affect the yield, no? When you say yield, yun yung dami ng products na makukuha, no? Okay? So, in some cases, this can tell you about the efficiency of a given chemical reaction in your laboratory setup, no? So, for example, you are going to extract one chemical substance from a sample, no? So, kunwari, liver. Gusto mo kunin yung few nutrients from the liver. Kunwari, gusto mo kunin yung nitrogen from the liver, no? So, maraming methods yon. We can have Kendall method, no? And the other methods, no? So, each method will give you different percent yield, no? So, the highest percent yield that will tell you that the method you use, no, yung process na ginamit mo ay efficient. So, it is better than the rest, no? So, yun lang yung kwento niya. So, what can the percent yield tell us? It can tell us about the relative amount of your product obtained in theory, no, kaysa sa theoretical yield. And also, we can use the idea of the percent yield, no, in establishing kung sino yung better na method, no? So, ito yung magsasabi sa atin kung sino yung better method. Pag mababa yung yield, pangit yung method. Sayang yung gamit, no? So, ano nyo to, ma-experience nyo to when you do your thesis, no? Okay, so, ako, buti na lang, no? Yung aking percentile doon nag-thesis ako is 90 plus, no? 94, 95%. So, that's not a waste of my money, no? Kasi if the percentile is much lower than that, then sad life, no? Ubus pera ko lalo, no? Pero buti na lang mataas yung percentile ko nun. So happy naman ako doon. So yun yung one use of this stoichiometry topic, no? Yung percentile, no? So the higher the yield, the better your method, no? So, ibig sabihin, okay yung ginawa mo. Okay? So, in doing percentile problems, we have to define three terms, no? So tatlo lang yan. AY, which is the actual yield, TY, which is the theoretical yield, and percent Y is the percent yield, no? So itong percent yield, this tells us about the ratio of our actual yield and the theoretical yield in percentage or times 100, no? So, yan. Pag sinabi nating actual yield, that tells us about the actual amount of product produced. Yun yung dami ng products you obtained after doing the chemical reaction. So again, this is after doing the chemical reaction. No? Okay, so actual yield, this tells you about the amounts of your products, the actual amounts of your products after doing the reaction. So tapos ka na mag-reaction, kinolect mo, then ayun yung actual yield mo. No? How about the theoretical yield? No? Theoretical, what does that mean? Meaning yan in theory, no? In calculations. Ano ba yung in calculations? Yung ating stoichiometry, no? So, the theoretical yield is the mass of the products that can be obtained by stoichiometry. Ito yung mga sinusolve natin kanina, no? Calculated yung mga yan. So, that means yung mga yield na nakuha natin kanina, yung amounts of products na nakuha natin kanina, that is the theoretical yield, no? Puro theoretical yield yung mga yon. Okay? So, sir, paano namin malalaman yung actual yield? Usually, the actual yield is stated. No? Sabi doon, if I only obtain 10 grams of this from the reaction blah blah blah, what is my percent yield? No? So, usually given itong actual yield. No? Okay? So, yan. Ito yung given. The theoretical yield, you can calculate it using stoichiometry, yung mga pinagagawa nating limiting and excess reagents kanina. And then the percent yield, just to obtain that, you just have to divide this by this, the AY divided by the TY. Make sure that they have the same units, no? But hindi naman necessary na mass, no? Pwede ring moles, no? Okay, so yan. So you divide them, then you multiply it by 100, you have the percent yield, no? So the lower your percent yield is, the uglier your methods, no? Pangit yung methods niya. So kailangan mas mataas eh. So let's have this problem. Okay, so let's have this problem. What is the percent yield if 14.23 grams of ammonia is produced when 15.01 grams of N2 is reacted with excess hydrogen gas? Okay, so chop-chopin natin yung problem. Ma'am, basahin ng problem ha. Okay. So sabi dito, we have 14.23 grams of ammonia produced. So, ibig sabihin, ito na yung amount ng ating product na nabuo, no? So, this is the actual amount of the product used, the actual amount of the products, no? Basta check nyo lang yung sentence, ha? Check nyo yung grammar niya. So, past tense eh. Produce daw. So, ibig sabihin, tapos na yung reaction. Ayan yung nakuha niya, no? So, this serves as our actual yield, no? Okay? So, ganun. So, ganito daw karami yung product na na-produce nung nireact niya ito with excess hydrogen gas, no? Okay, so this is your reagent, no? This is your reactant. Tapos, ito yung reaction. Then, Yun. Ito lang yung nakuha niya. Okay. So, ganito yung technique dito. So, you have to identify the actual yield, no? So, ito yung actual yield. Then, you have to check kung ano yung pwedeng gamitin in stoichiometry in solving for the theoretical yield, no? Okay. So, the first thing you have to do is to solve first for the theoretical yield if not given, no? So, if not given, edi solve natin. So, let's solve for the theoretical yield of NH3 from 15.01 grams of N2. 15.01 grams of N2 yan. So, paano natin kukunin yung amounts of products from our reactants? Ito lang yan, no? So, convert mo yung mass ng reactant into moles, no, of reactant. So, ito yung equation, mass over molar mass. Then once you have the moles of your reactant, you have to convert that into the moles of your of your product, no. So ito na yung stoichiometric relationship, no. Just look at the equation. The ratio of N2 and NH3 is 1 to 2. So ilagay mo lang doon yung 1 to 2. Ito yung conversion. So dito we have highlight natin. In this part you have the mole of reactant. This is the conversion. And pag na-convert mo yan, you have the moles of the products already. Ang purpose ng nasa dulo is to convert that into mass, no? So, convert into mass, no? Into mass product. Okay. Kasi ang tanong dito, mass no? Okay, so convert natin yung moles of the reactant into the mass of the products, no? So, you just do this equation. Kunin mo muna yung mole ng reactant mo, convert that mole reactant to mole product, then yung mole product, i-convert mo to mass of the product. No? So this is the format of the equation. So yan, so that's 1501 divided by 28014, convert, times this, times that. This is the molar mass of NH3. So you have 18.25 grams of NH3. No? So ano tawag natin dito? This is the amount of the product that should be produced in theory. Okay? So this is the amount of product theoretically. Theoretically. So, yan yung amount ng product na mapoproduce in theory. Okay? So, in stoichiometric basis, no? Pero yung actual, ilan kaya, no? So, dapat 18 daw. Pero yung actual na nakuha natin ay 14. So, we can now solve for the percent yield. So, let's do that. So, solving for the percent yield, that is the actual yield, which is 1423, divided by the theoretical yield, which is 1825. You do that, you have 77.97% yield now. So that means mayroon kang 22.03% na nawala in the process. No? You lost that amount of product. No? Pero good thing na rin na malaki din yung ayan. So siguro pangit yung methods or may leak sa reaction kaya bumaba yung percent yield na. So ganun lang. Ano uli gagawin nyo? So from the reactant, you have to solve for the theoretical yield, no? Usually the actual yield is given, no? Usually, no? So after obtaining the theoretical yield, you divide the actual yield by it, no? Para makuha yung percent yield. So ganun lang. Okay? So yan, you can use this problem as your reference. So ganun lang, and let's have the last two questions. Ito basic na lang. Binasican ko na lang din sa quiz yung percent yield. Pero again, yung concept ng stoichiometry, paulit-ulit lang. Okay? So yan. Let's have this. In an experiment forming ethanol, the theoretical yield is 50.5 grams. If the percent yield is 64.25%, what is the actual yield? No? Okay, so sagutan natin yan. So number one, your theoretical yield is 50.5 grams. Your actual yield is question mark, and the percent yield is 64.25% na. Okay. Mm. So, ang hinahanap pala dito yung actual yield na. Sabi ko nga, given usually yung actual yield. Pero, when I say usually, it doesn't mean always na. So, madalas lang. Okay, so let's solve for this. So, we are given theoretical yield, then we will solve for the actual yield. No? So, madali lang yan. Just write the formula, percent y equals AY over TY times 100. Okay, so we will solve for the AY. All we have to do is to cross multiply TY and the 100 na. Okay, so cancel natin yung TY, 100 din. So that's percent Y times TY over 100. So yung numbers na lang ilalagay ko. That's 64.25 times 50.5 grams divided by 100. Let me solve. So that's 32.45 grams yung actual yield na. So, yan. So, the actual yield in this experiment is 32.45. What can you notice? The amount of the actual yield, no? Yung actual yield natin, that is usually lower than the theoretical yield, no? So, usually ganun. So, may times na higher yung actual yield kaysa sa theoretical yield kapag ang percent yield ay 100% pataas, no? So, that's normal. In laboratories, nangyayari talaga yan, no? Pero if your percent yield is less than 100, then you should expect that your actual yield is lesser than the theoretical yield, no? So, we're satisfied by that, no? Satisfied na ako dyan. So, let's do number 2. In an experiment to prepare aspirin, the actual yield is 124.5 grams. If the percent yield is 94.25%, which is the theoretical yield. Okay, so madali lang to. Again, manipulation of the equation lang. Manipulate lang natin, no? So this is percent y, AY over TY times 100. We are going to solve for the TY. So that's TY over percent y. So yan. So cancel natin yung TY dito. Percent y cancel natin doon. So we'll have TY equals AY over times 100 divided by percent y. Okay, so TY, that's 124.5 grams times 100 divided by theoretic percent yield, no? 94.25. So TY, ano yung ating theoretical yield. So the theoretical yield is 132.09510 grams. No? Okay, so yeah. So usually again, when your actual yield, when your percent yield is less than 100, the theoretical yield is greater than the actual yield. No? So yun lang. So that sums up chapter 4. No? So na-discuss na natin yung limiting and excess reagent and yung percent yield. No? So again, so ano lang, what you can observe is paulit-ulit lang siya na stoic. No? Ulit-ulit lang na stoic. No? So kaya you have to master the stoichiometry. So pag nakita nyo na yung limiting and excess reagent problem, madali na lang, no? So, paano uli ginagawa yung limiting and excess reagent problem? All you have to do is to convert your reactants to the product. Convert mo ito to product, no? Then, to identify the limiting reagent that will give you the least amount of the product, no? And the excess reagent will give you the most amount of the product, no? So, in identifying the theoretical yield, ano, in identifying the theoretical yield, you use the limiting reagent amount of product, no? So, yung mabibigay ng limiting reagent. So, this will be our theoretical yield. So, this is theoretical yield. Ano yung actual? Yung actual yield, usually given yan sa problem, no? So, given yan. So, let's have this one, no? So, ganun din. You have two amounts of reactants. Convert mo lang sila into products. Then again, yung pinaka-onting amounts ng reactant, onting amount ng product na mapoproduce that will correspond to your limiting reagent. No? Anything in excess will be your excess reagent. So kapag tinanong sa inyo yung amount of the product produced, use the limiting reagent. No? Okay, so itong 13.32 grams, this is your theoretical yield. No? Okay, so again, ano yung task nyo, no? So, tapos na tayo no? So, by the way, no? So, I want you to, ano na lang, to answer some of the items here in the time discussions. For example, ito nga, no? So, ito, this is a limiting and excess reagent problem. Ang problema lang dito, you have 5 grams of this, 5 grams of this, 5 grams of this. You have to convert all of them to HgCl2. Tapos alamin nyo kung sino yung limiting reagent. Na, so ganun. Tapos pag alam nyo na kung sino yung limiting reagent, that will tell you how much product is actually formed. Na? So ganun lang. So paulit-ulit lang naman yan eh. So ito, one item. So when iron and steam reacts at high temperature, blah blah blah, how much iron must react with steam? So this is a trick question. So you are given the reaction yield, you are given the theoretical yield, no? So ito yung theoretical yield nyo. And I know this is the actual yield pala. So this is your percent yield, this is your actual yield, no? Then naalamin mo how much iron is left na. So kumbaga reverse process to. So I will give you time no to think about this problem. So again, this is a trick question. So good luck na. So I will upload the file no, yung answer key sa lahat ng worksheet dito. Atong worksheet 4.1 pati 4.2. Upload ko yan no, after the discussion. No? Siguro by Thursday, bibigay ko sila as we start the chapter 5 discussion. No? So, yun lang. So, I hope na may nakuha kayong idea kahit papano. And again, paulit-ulit lang na stoichiometry to. No? So, I know you can ace the quiz. No? Okay, so yun pala. Ginawa ko pala kagabi sa Canvas. No? Kaya, ang dami yung notif siguro kaninang umaga is that pinost ko na kasi lahat ng quiz. No? Na quiz sa midterm. So, mayroon na kayong quiz for the laboratory. So, yan. Ito yung kanyang scope, no? And you have quiz na rin, quiz 5 for the laboratory, which is on the gas loss, no? Ito, kung gusto nyo nagsagutan to, di sige, no? Gas loss lang naman yan eh. No? So, alam ko, purgang-purga na tayo dyan, no? Okay, so yan lang. And the deadlines for quiz 4 and quiz 5, ginawa ko siyang October 11, a day before your midterm exam, which is on October 12 to October 14. Okay, so yan. So, it doesn't mean na you have to do it on the deadline. Kung kaya niyo na sagutan, sagutan niyo na. So the reason why I gave you big scope lang is for you to study well before you take the quiz na, para no pressures. So yun lang. So thank you for watching this video. So I hope na may natutunan. Okay, so if you have any questions, just raise them to me, no? So stay safe and I'll see you on Thursday and Friday. So bye-bye. Yun lang po. Bye-bye.